So Jessica started a new bracelet company. Her net monthly profit in hundreds of dollars is modeled by h of x here. What type of function is this? Polynomial. Very good. What's the degree of it? What is the degree of it? Did you say 5? Wait a minute, I'm lost. What is the degree of it? And you said I? Oh, odd. You are correct. Sorry. Specifically, what number? 3. The fact that it is odd, though, what does that tell you about its end behavior? Opposite. So it either starts low, ends high, or starts high, ends low. Based on the fact, well, that it's a positive x cubed. Does it, which one is it? Start low, end high, or start high, end low? Start low and high. It's got to go upwards with a positive slope, okay? So where x is the month of the year, x equals 1 is January. Graph Jessica's profit function on the axis provided using the domain, so 1 through 12. Okay, so you obviously have your calculator. Anytime it says to graph, use your calculator. They want us to do it specifically for month 1, month 2, all the way through month 12. So the best way to do this is just type it in and look at your table. X to the 3rd power minus 18x squared, oh boy, plus 92x minus 120. And I don't know what your table is set up at, but if you go to second window, you can set up your table to start at 1 and change in increments of 1. So now when I look at my table, it's exactly the points that I want. 1, negative 45. 2, 0. 321. Some of these you're obviously estimating. 424. I will tell you this as you're graphing. It always boggles our mind when we get to a graphing question on the Regents. How could it ever not be perfect when you have your calculator in front of you? That is a heartbreaker for us because, yes, there are ways to do things by hand, but if you have your calculator and you can look at the table points, pull them. You have so much time on the Regents, so if you need to be overly exact, do it. Okay? Andy, question? Oh, you were out yesterday? Yeah. Sorry, not sitting there. When we're done with this problem, you may. Where would I leave off? 4, 5, 15, 6, 0, 7, negative 15, 8, negative 24, 9, negative 21, 10, 0, 12, 120. I didn't grab 0 from my table, but that's the y-intercept. What should it be? Negative 120. Because technically they just said using the domain 1, 2, 3, 10, 12. Honestly, because they said that, and they did not say use 1 to 12 like this. They didn't say to use everything in between 1 to 12. They literally said use 1, use 2, use 3. So we should not be connecting these points. Okay? I'd have to look at a rubric to see if they would take off for that. But this is not a continuous. They want the profit at the 1 month mark, the 2 month mark, so obviously they're not looking at profits in between. That's just like a little tricky math technicality thing. In what month did Jessica make the most money? What would you say for that? Aiden? December, very good. During what month did her profit decrease? What month or months would that ask? Did her profit decrease from the previous month? What would you say? Give me something to start with. McKenna. Okay, well then come get one, please. What'd you say, Mason? 4, 3, 8. 4 through 8. I would only say one of those is technically incorrect. During what months did her profit decrease from the previous month? Which one would you not include? Mason said 4, 5, 6, 7, and 8. Andrew. Right. 4 did not decrease from the previous month. 4 actually increased from the previous month. Yes? So 5, 6, 7, and 8. May, June, July, August if you want. Do you think G of X will model Jessica's profits over the next year where X is an integer such that X is between 13 and 24? In other words, will this pattern continue? Explain why you think what you think. Maggie, do you think this pattern and her profits will continue to follow this curve? And I would say maybe either answer is fine here. It just depends on how you sell it with your explanation. So right now the pattern, and I'm going to do this even though we're not going to do it as part of our problem. Our pattern is this. What's your gut tell you? In months 13 through 24. Okay. Why is your gut saying that? Well, this is the function. This function is definitely not going to wrap back around again because then it would have a different degree. The degree is 3. So we've got our 3 roots and we are done turning around. So I think maybe you're thinking of it like a trig graph in a sense where it would just kind of the cycle would repeat itself. But we're not going with that avenue. Lydia, what would you say? And what's wrong with that? Okay. I think we're missing an idea, Nathan. Right. It's not really realistic to think that her profits are going to skyrocket, right? Eventually her profits, they might increase forever, but they would probably realistically balance out, right? And then maybe she, innovates a little bit and comes up with a new product and it fluctuates a little more and goes and shoots up at given moments depending on what her business plan is. But I don't think any company is going to just exponentially go to infinity. Okay? So it's just more of like going back to reality and lots of times functions are great to model little intervals, but they don't, because most things kind of shoot off towards infinity or do something, they don't always give you the absolute best thing for an eternity. So I would say stay with no, because it's unlikely her profits, and the profit is in hundreds. So right now it's 150 hundreds, which is 15,000. 150 hundreds. Second quit. 150 times 100. Yeah, 15,000. Her profits will increase towards infinity, really, through the next 12 months. Or you could say unrealistic. Thinking about reality and what we're modeling here, why in month 0 is she at negative 120? What'd you say? Right. So she obviously, or they could ask you this, how much money did she put into her company, right, before she started it? That would be $12,000, right? So she invested $12,000 to start her business. She had to buy materials, she had to create a web page for advertisement, you name all the potential costs. And then you might be asked the question, when does she break even? How long until she breaks even? In the second month. So by month 2 of actually selling the jewelry, she has gotten back to a profit of $0. So she's broken even. Then she goes above. What do you think happened at month 4? Stopped buying it? Oh, maybe that. Maybe she ran out of materials. She had to buy more, so she lost more money because she had to purchase supplies. So she went down again over the next few months. She dropped all the while, and then she started, selling again. And there's likely over time always going to be drops and rises and drops and rises because she's going to be having to buy. More materials. Okay. So anyway, that's a little bit of interpreting the graph in the context of the problem, so understanding the connection there. That is all for test 2 other than your homework for tonight. Did I mention my add-ons to the flashcards in this class? I didn't? I didn't go through the ones from last year just in case I didn't. I thought I did. I think period 9 is the one I didn't. But I went through my last year's flashcards, and these are the 5 add-ons that I somehow fell asleep. I did talk about this. I fell asleep during the trig chapter and forgot to put some important facts up. No? Oh, all right. So the arc length formula, the SOAR formula, that actually came up on last night's homework, didn't it? I can't believe I didn't have a flashcard for that all along here. That's important. The biggest importance there is obviously, aside from remembering it and knowing what to use it for, the theta has to be in radians. So I think on the homework last night it was 120 degrees. You had to convert that to radians first to use that formula. Pythagorean identity, just knowing that sine squared plus cosine squared is 1. Okay, sine squared of 15 plus cosine squared of 15, 1. Sine squared of a star plus cosine squared of the star is 1. Reciprocal functions, these come up, but you have to know these, right? Cosecant is 1 over sine, secant 1 over cosine, and cotangent 1 over tangent. So know those. Change of base formula. So I don't know how, but I know they'll find a way. I know that on your calculator you guys type in log base 5 of 6 just by going to your math function and going all the way down to log base and just grabbing it, log base 5 of 6. But you also need to know that there's a way to do that without having to go into that functionality. Again, I don't know how they'll ask it, maybe with variables, but they will. That you just take the log of 6 and divide it by the log of 5, and you have that log button right on your main panel. Log of 6 divided by log of 5, and you'll get the same answer. As long as whatever log you take has the same base, which this one obviously does because it's a base of 10. With that being said, the same thing will also work for ln of 6 divided by ln of 5. because those are just a log with the same base of e will give you the same answer. Do you follow? Okay, so change of base formula, and I just gave a numerical example, log 6 over log 5, or natural log of 6 over natural log of 5. And then I know we have the structure for the trig function, but identifying what the variables stand for. A is not the amplitude always. The absolute value of A is the amplitude. Even on yesterday's homework quiz, a lot of people put that the amplitude was negative 30. No, the amplitude was 30. The amplitude is always the absolute value of A. B is technically the frequency, but mainly it's used to calculate the period, which is 2 pi over B. C is our phase shift, and D is the midline. So a lot of you know some of those, but those and between the flashcards we came up with this year and like these few that I used last year and forgot, I don't think there's any key fact that we've left out. Okay? So what dawned on me about some of these, like for example, the parent graph of a log function, because when people were taking that flashcard test last week, someone pulled out their calculator. And I was like, what could they possibly be doing on the flashcard test on their calculator? And they were typing in log base whatever of whatever and just looking at the parent function and putting the sketch down if they forget. So keep in mind that you can always do that on a test. If you don't remember, if it's a transformation type question or you don't remember what the parent graph looks like, just to get the visual in your head, you can just type it in. So obviously you have to know like what the function looks like. Like rational function you have to know is 1 over x. Where is that? Here. Rational parent graph, you would have to know that that equals 1 over x. But then you could just get a feel for the parent graph there. So in hindsight, that's silly to make you memorize those. I should just make you memorize what's rational function means 1 over x. But you will be getting those flashcard tests back. Not right now, but soon. And when you do, I am going to allow people to take it again as a way of improving. It's not going to totally replace it, but to improve your flashcard test.